Hello and welcome to another episode of Pinnacle Academy. I'm your host, Sannel Patel, Director of Business Development and Marketing at Pinnacle Ozone Solutions and a chemical engineer. Today, we're taking a deep dive into the ozone in aquaculture with a special focus in Europe and RAS systems. This is a growing collaboration that we have between BioUV and Pinnacle. Joining me together are our two guests from BioUV team, both Roy and Michael. Roy, who is a global aquaculture marketing specialist, and then we have Michael, who's the ozone product manager, both at BioUV. Roy and Michael, thank you both for being here with me.
Thanks, Sannel. Great to be here.
Let's start by basically introducing BioUV. Roy, can you give us a quick overview of the company background and your mission in treating ozone or using ozone to treat water, aquaculture, and just where ozone fits into you guys' application?
BioUV Group has over 2 decades of experience in advanced water treatment with strong roots in disinfection across municipal, industrial, and aquaculture markets. Over the last few years, our focus has switched slightly and expanded significantly into ozone-based process treatment, particularly for rice and high-intensity aquaculture production systems. My mission is to deliver engineered, reliable treatment solutions that directly support production performance, biosecurity, and long-term sustainability. And in that context, ozone has become cornerstone technology for us, not only as a disinfectant, but also as a process tool for organic load reduction, color management and removal, fine solids control, and overall system stability. The one thing about a well-functioning rice is if it's stable, it works well and the fish perform well. And that's exactly why our collaboration with Pinnacle is so important, because Pinnacle's ozone technology brings industrial-grade reliability, precision control, and scalability that align perfectly with the demands of modern aquaculture systems, particularly in Europe.
So BioUV has been a key distribution and integration partner for Pinnacle in Europe. Michael, coming to you on this, how did this relationship start? How did you see what makes Pinnacle technology different or good fit for BioUV's portfolio?
Yeah, so I met Philippe, the Pinnacle's global sales manager at Aquanor exhibition in late 2023. And at the time, he was looking for a global partner to support Pinnacle's expansion outside of the Americas. We, at the same time, had just launched our PPO3 range of ozone generators, capping around 1.5 kilograms per hour of ozone output. And we were deciding what to do for the larger capacities at the time. So it was really perfect timing for BioUV. Pinnacle's a good fit for BioUV's portfolio for, I'd say, 3 main reasons. So the first one is that Pinnacle's product range and market focus fit really neatly against our own portfolio and market focus, with us covering generators again up to around 1.5 kilograms an hour of output, and Pinnacle covering up to around 15 kilograms per hour for a single generator. And also with us focusing on the global markets outside of the Americas, whereas Pinnacle's home base is in the Americas. So in terms of product and market fit, it was a really hand-in-glove fit. The second reason is that Pinnacle generators are really some of the best out there with market-leading efficiency, controllability, durability, and modularity, as Roy mentioned as well. And they were on my radar. Pinnacle was on my radar well before meeting with Philippe, and so I knew how good the generators were at the time. Thirdly, having access to a completely new team of ozone specialists, so I probably didn't fully grasp the benefits of that at the time. But since we met, we have worked very closely with the entire Pinnacle team, and there's been some really significant learning on both sides. And that's valuable, not only for ongoing development of our respective teams, but in the moments when it matters most, 2 brains are better than 1.
So I see that BioUV has done really well in Europe. For a second, what I want to do is I want to zoom out for a little while. Let's zoom out and understand this a little bit. So, Michael, can you help our viewers understand the role of ozone that it plays across water treatment in Europe, especially in aquaculture? And are there any differences in regulations versus technical expectations versus what's in the Americas?
Yeah, so I think firstly, ozone is ozone. Customers are customers everywhere you go. Ozone is a really potent technology, has real benefits in real-world applications, and that's truer than ever in aquaculture. But any application of ozone has to follow our clients' North Star goals So in aquaculture, that's more fish and better quality fish per unit of input. So that unit of input includes energy, water consumption, and the risk premium of poor quality design, products, or operation. Regarding technical expectations, there are fewer cultural differences, I guess, than there are between different types of customers and end users in general. So, for example, you can have really highly technical customers who want to be involved in all parts of the system design and the process. And you can have others that are more focused on finding a partner they can, I guess, trust to deliver that on their behalf. And overall, we take the same approach with both types of customers, again, focusing on their North Star objectives and just adjusting our working style to best achieve those outcomes for them and with them. On the other hand, for regulatory expectations, quite a lot. The differences are a bit greater. So mostly because of the different regulatory approaches taken in Europe and the UK compared to those taken in the US or other jurisdictions. This is well understood by anyone that has experience with both CE and UL compliance, for example. They're just so different, but each really requires a different approach to design and testing to be compliant. But in Europe and the UK, ozone for biocidal use anyway, is also subject to the respective BPR legislations, the biocidal product regulations. These create requirements to prove empirically efficacy, safety, and environmental protection. Covers the chemistry of ozone, the compliance of the ozone generators themselves, the real-world operation of those generators, the disinfection claims made. And that really is a step change compared to the previous regulatory framework here in Europe and compared to current frameworks in other jurisdictions, including the US. But it's also an opportunity to validate performance and shape these regulations to the benefit of compliant companies like ourselves and our customers, as well as to better communicate how ozone works to customers that are not familiar with it, because we have a framework based on the legislation and based on the applications, that the validated applications that we can present to customers.
So do you see like the UL 508A, which Pinnacle is certified, and the CE certification that Pinnacle has provided for BioUV? Is there any additional layers that your customers have asked for that you guys have worked on? What other certifications are customers demanding on right now for projects?
Yeah, so CE and UL compliance specifically for engineered products within the different territories. And as you mentioned, Pinnacle products are now fully UL and CE compliant as well, which allows us to market them in our home territory in Europe and the UK. But on top of that, in Europe, we have the biocidal product regulations, which in Europe and in the UK, they're two separate regulations. And they define ozone uniquely in the world as a chemical biocide, effectively, which means we're not just in the engineering industry, we're in the chemical industry at the same time as well, yeah. Which is a whole new level of compliance. And that's really the main regulatory focus in Europe and the UK. There's also REACH, which is for non-biocidal applications, but typically we're focusing on biocidal applications in aquaculture, for example, where it's specifically defined as a biocidal application.
So, Roy, coming to you with this question, from a market and system perspective, what makes Pinnacle quad block technology a good match for us? How do you see liability, footprint, and even the controllability into the projects that you're currently working? What are the decisions that have to be made for this?
Well, I think from a RAS market perspective, Pinnacle's quad block technology, it really addresses the key sort of decision drivers that we're seeing on these large commercial projects. Reliability is first. One thing about a RAS facility is it operates 24/7 continuously, and ozone is a mission, critical process. I think quad blocks, modular architecture, electrical robustness and built-in redundancy really provide that confidence that the systems will perform consistently over, many, many years. And, footprint and integration also crucial. RAS plants are highly engineered environments with very limited space, as we've seen on some recent projects. And the quad block systems offer compact, scalable solutions that integrates well within centralized water treatment rooms without excessive infrastructure burdens. And finally, on control and responsiveness, modern RASs also require ozone systems that can respond dynamically to changes in feed load, biomass, variable water quality. And Pinnacle's control philosophy supports precise adjustment and seamless PLC integration, which again is essential when ozone is used as a primary process tool rather than a secondary add-on.
So in RAS, do you normally have additional products that you're pairing with the ozone system? How are you going about in designing the ozone system for that application?
It depends where, ozone, one of the things you have to be careful of with ozone is that it can be detrimental to fish. So while it's extremely positive on one hand, it does come with a small associated risk, which can be well managed. So you would pair typically ozone and UV and on your influent water treatment. Then you would use the ozone systems in your process water, so in your loop water, your RAS itself, and that provides the clarity that's needed, the reduction of the organic loads, and some background sterilization. And then post that, you can have further, ultraviolet for further disinfection. But normally it would be a combination of both on influent, ozone only during the process, the RAS loop itself, and then a combination of ozone and UV on effluent.
And what is the ozone doing in this case? Is it helping with sanitization? Is there certain compounds that you're trying to treat? What are the problem materials or compounds that you're working with in the UK and in Europe to deal with RAS?
I think in salmon RAS, which is where most of our exposure is, it's really control of the organic load in the system. You must remember in the RAS, you are recirculating, up to 99.9% of the water. So, typically on a flow through, you would have a lot of fresh water coming in, flushing out, any of the dissolved solid in the water. In a RAS, that doesn't exist. So ozone provides that critical tool to, keep the organic load down in the system.
And is most of the time is the RAS application, is that freshwater application or is that seawater? Do you guys have a certain preference in terms of what type of RAS system you're looking at?
It will be both. We work across the full envelope of fresh and seawater. Seawater comes with some unique challenges because of the high bromide content of seawater. But again, it's down to management and control. With the Pinnacle systems and the right control, those are effectively managed.
And just a question for our listeners here is that, so bromide, there are some issues that come along with bromide. Can you quickly just give us a short explanation on what issues could arise if you over-ozonate the bromide?
So the real issue with bromate, in fact, it is produced when there are high bromide levels in the source water, and seawater has extremely high bromide levels, high in the context of when bromide and ozone meet. There's some other chemistry around it as well. High levels of bromate are produced. Basically, a portion of that bromide is converted into bromate by the ozone in various levels, depending on the conditions. And that bromate is carcinogenic to humans. The regulatory standard for drinking water for humans is 10 parts per billion, so it's very low. And also it's dangerous to the fish life cycle, to the fish health. Yeah, there's a potential for crossover into the food supply then as well. So it's all of those things being considered. So we've seen facilities that use synthetic seawater made to mirror seawater, except without the bromide ions there. And we've seen seawater facilities use ozone, but with very careful titration of the ozone dose, looking at the process properly to make sure that, and monitoring, of course, to make sure that the bromate levels do not exceed the limits for the facility and for the type of fish.
So you're monitoring those levels constantly just to ensure that doesn't take place in the process.
Yeah, it's really holistic though, and it really depends on the type of system and where it is and which type of fish, the water matrix, the ozone dose needed to achieve the requirement as well, because you have very much lower doses for certain targets than you do for others. And it depends on the contact time as well and the chemistry of the water more generally. So monitoring is crucial, but system design is thinking about this before you put equipment on the ground is probably more crucial to make sure that the system's capable of turning down, up and down to the right level to dose perfectly the amount of ozone that's needed without risking too much bromate.
Thank you so much.
I think what's really important, to note for our viewers is that, it really echoes what Michael is, saying there is we have the skills, we have, the technical ability to look at all the risks, understand them, and design, systems correctly. So we're not just an equipment supplier. We don't just want to, sell you an ozone generator and leave it there. What we really want to do is get involved in the whole solution to ensure that when an operator, a RAS farm, company, installs, they have a reliable, robust, solution that protects people, protects the livestock, and ensures good production.
So looking ahead, let's start with Michael for you first. In your role supporting BioUV and Pinnacle products, what are some of the most common questions and misconceptions you encounter when you deal with just ozone as a whole and in aquaculture?
Yes, there are many common threads questioning for ozone. The list is quite long. That ozone is a relatively niche industry in the wider water treatment industry, and many of our customers, aquaculture farm operators, for example, they may have experience with ozone, but they're not ozone experts, and they're not water treatment experts necessarily as well. So the biggest misconception that I would say there's one that really covers them all. Is that ozone is a nice to have in aquaculture farms. That's the biggest misconception that kind of covers everything. There are really two root causes of this misconception. The first is technical inexperience or fear of the unknown. So, I mean, if someone has run fish farms without ozone in the past, they may not be aware of the benefits and can be really unwilling to take what they perceive as a risk using ozone for the first time. And they also don't know the potential benefits of ozone in their system. The other root cause is the opposite of that, and is technical experience in the bad sense. So this is also very common, where a client has sometimes quite extensive experience with ozone, but with poor quality or outdated generators, very poor system implementation, and or poor reliability, whether that's because their suppliers were running sell and forget model, as Roy mentioned before, or because of poor system maintenance leading to premature failure in the past. So it's quite difficult because you have operators or facility managers who have worked with ozone for many, many years, and they've always had problems with it because they were using the wrong product. It was not installed properly, or they had other things, lack of maintenance, things like this. Obviously, it's difficult to counter that, but I think from our side, ozone is not recommended for each and every fish farm, and that's why it's so important to have a trusted supplier who are focused on delivering long-term value and a solution. In the applications where ozone does play a role, it really is a must-have. The benefits are really wide-ranging, again, as Roy talked about earlier, and that's true whether we're talking about a specific target like microbiological control or microbiological risk management, or a specific water quality target, or more broadly about systemic design to maximize fish yield and quality of fish per unit of output. So that's the broad, again, the North Star of an aquaculture farm. Maximize fish yield, maximize fish quality per unit of input. And those inputs are, again, energy, water consumption, labor, and risk management primarily, as well as capital cost and feedstock and things like that.
So Roy, touching here on the last question here, so where do you see ozone playing in terms of the greater role in features of sustainability in aquaculture in Europe? Like, what do you envision happening over the next, not just year, but over the next 5 years or so?
And looking ahead, I see ozone becoming even more central into how, certain European aquaculture facilities are designed and operated. RAS projects are scaling up, and they're scaling up quickly. Operators are becoming increasingly under more pressure to, maximize water reuse, reduce discharge impacts, and maintain very, very tight water quality control to, again, support production. And ozone is uniquely positioned to address these challenges, particularly when applied upstream of filtration, protein skimming, and ultraviolet sterilization. We're also seeing a growing recognition of ozone's role in system robustness, stabilizing water quality, protecting biofilters, and improving process resilience. And in that environment, the quality of the ozone system itself becomes critical to these operations. So the future isn't about higher ozone doses, it's about better ozone systems, reliable, controllable, fully integrated. And that's where Pinnacle stands out, why I see Pinnacle ozone technology playing a key role in the next generation of sustainable, large-scale aquaculture systems in Europe and globally.
Thank you so much. So, Roy, Michael, thank you again for this great conversation. It has been intriguing. It's been good to understand the point of view, what you guys see on a day-to-day basis, not just in UK, but in Europe as well. So thank you once again. To everyone watching, if you're interested in learning more about BioUV or how ozone is supporting the sustainable aquaculture, please visit biouv.com or pinnacleozone.com. Thanks for watching this episode of Pinnacle Academy, and we hope to see you soon. Thank you.